Stan Gibilisco here, with a little riddle, perhaps answered, perhaps not, based on an email I got today. This person confesses that it's kind of driving him batty, cuckoo. It's bugging him. Which direction should current be considered to flow when you are reading a schematic diagram? It was basically his question as I understand it. In what direction do you consider current to flow? Well, I consider current to flow from minus to plus when reading a schematic diagram. But current is a great deal more complicated than just something that flows from minus to plus, like water in a hose from the faucet through the nozzle. First of all, current does not really flow as such, but at least it doesn't in electronic circuits. Rather, it jumps from atom to atom in a particular direction, and that direction is actually entirely arbitrary. It doesn't matter as long as you stay with the same principle and the same convention throughout your analysis. Most people, I think, consider current in an electronic circuit, like in Beginner's Guide to Reading Schematics, think of it as flowing from the minus or negative terminal to the plus or positive terminal, because the actual charge carriers are electrons. But this question really is sort of like a riddle in the sense it's how much wood could a woodchuck chuck if a woodchuck could chuck wood? Or, to rob Hank Ketchum's Dennis the Menace, and I don't know if he's the first guy who came up with it, how much ground could a groundhog grind if a groundhog could grind ground? Because when you generalize as to what direction does current flow in the real world, it's an unanswerable question. For example, when the sun has a coronal mass ejection and sends a bunch of ions spewing out, hopefully not in our direction, those ions are charge carriers. And they really are flowing, sort of like air molecules flowing in a wind. In fact, sometimes they call it the solar wind. That's an electric current, just as much as the current in an electronic circuit is. Current is the movement of charge carriers. A charge carrier being a particle that carries an electric charge. It can be a positive charge, it can be a negative charge, it can be a unit positive, or several units, or a unit negative, or several units negative. It can flow in the sense that flow implies a smooth movement of charge carriers. So we're dealing with a bunch of semantics here, and some of the reference sites say just about as much. And it also, in most cases, matters little whether you consider current to flow or whether you consider it as a jump from atom to atom, or whether you consider it as flowing from minus to plus or plus to minus. These are all conventions that we have adopted for our convenience. I can tell you one thing. If a current is strong enough, if there are enough charge carriers flowing past a given point per second, and that second, or that given point happens to be your heart muscle, and that current happens to be 100 milliamps or more, you are in trouble. Now, am I making any sense? I hope not. But I hope really, honestly, that we can clear up any concerns that amount to, and to quote a more familiar quote, much ado about nothing, or it doesn't really matter as long as we stick with the same convention throughout any given single analysis, and as long as we don't get electrocuted. Stan Gibilisco signing off with a somewhat facetious response to a question that I don't mean to make fun of my viewer, but I think that when I think of current flowing in an electronic circuit, especially in a schematic diagram, I always imagine it going from minus to plus. That's just me. Maybe you like some other method, like beer batter fried charge carriers. Don't bread them, not breaded charge carriers. Or you can saute them in garlic and onion and butter. Sauteed charge carriers. They flow from your mouth through your stomach and they're onwards. Do they? Stan Gibilisco, once again, saying, best regards, have a good night. Hope you don't get any of this. I hope it's total nonsense. If so, I've accomplished my goal with flying colors. How do colors fly? I didn't know they could. Oh well. So long.